Hello everyone. So in this video, I will present a research about design of information monitoring system for floods based on IoT. This research leveraged IoT technology to address one of Indonesia critical issue, yep, floods management. This research is based on the work conducted by Dedi Satria, Saifuddin Yana, Rizal Munadi, and Xiaomi Shahreza. They are researchers from University Serambi Mekah and University Syiah Kuliah Indonesia who contribute to development this system. Now, let us explore how this system works and its potential impact on disaster preparedness and mitigation. And here's an overview of my presentations. We will begin with an introduction to the problem, followed by researcher objective, methodology, system components, and design. I will then share the research results and conclude with the significance of the findings. Let us start with the introductions, where we explore the background and problem is research aims to address. In Indonesia, as we know, flooding is a frequent and destructive natural disaster, leading to significant losses. Current flood information systems often rely on slow and outdated methods, such as verbal communication authorities. This research aims to address these inefficiencies by utilizing an Internet of Things to provide real-time monitoring and faster, more reliable alerts. With this background in mind, let us now move to the research objectives and what this research aims to achieve. And yeah, this is the primary objective of this research is to develop a real-time flood monitoring system using IoT. The system is designed to detect water levels and rain conditions to provide this information through a website interface. This innovation enhances the speed, accuracy, and accessibility of flood-related data, helping to improve disaster preparedness. Now that we understand the objectives of this research, let us delve into the methodology used to achieve these goals. And yeah, the authors followed the software development life cycle, or we can call it as DLC, methodology to develop the system. This process consists of 5 main stages. The first one is analyze. This stage is for identifying the system requirements and understanding the needs of the users. Number 2, design. Creating the system architecture and selecting appropriate hardware and software components. Number 3, implementations. This stage is for building the system by integrating the selected components and developing the necessary software. And number 4, testing is for ensuring that the system functions as intended and meets the specified requirements. And the last one is maintenance. Maintenance is used for evaluating and improving the system to ensure long-term reliability and performance. And yeah, this structure approach allowed the authors to create an effective and user-friendly food monitoring system. With this methodology, let us now explore the components that make up the system. And okay, in these system components, there are some components including an HCSR04 ultrasonic sensor for water level detection, a rain sensor to monitor rainfall condition, an Arduino Uno with Atmega 238 microcontroller for data processing, an Internet Shield for connectivity, and the last one is TLMR 3020 wireless router to share data via the web. These components work together seamlessly to enable real-time monitoring and ensure the system delivers accurate and reliable flood data to users. With the components outlined, the next step is to see how they can work together in the system's design. And yeah, we move to the system design. This diagram illustrates the system design for flood monitoring prototype. The system consists of three main stages. The first stages is input. Data is collected using the rain sensor to detect rainfall and the ultrasonic sensor to measure water levels. Both sensors are integrated into a flood detector construction using a 5-inch parallel pipe. The second stages is processing. In these stages, the Arduino Uno microcontroller processes the input data. It calculates the flood level and weather conditions based on sensor readings. And the last stages or number 3 is output. The processor data is transmitted to a web server using the Ethernet shield and displayed in real time through a browser interface. This allows users to monitor flood conditions remotely. With the system design explained, let us move to the results of this research. Now, I will explain to you about the research results. As we know, this system has been successfully developed and tested. It provides real-time data on water levels and rainfall conditions via a web interface. This allows users to monitor flood risk and effectively. Here, you can see the system prototype and a visual representation of its web-based flood information display. Let us start by looking at the web interface output as shown in the first image. This is the output interface of the flood monitoring system. It shows real-time data, including the current flood level, which is 32 centimeter, and the weather condition indicate as raining. The system also categorized the flood status into secure, wary, or danger levels. And here it shows a danger level status. This information is accessible via a web browser by entering the system's IP address, providing users immediate updates on flood risk. Then we move to the next image. This second image illustrates the physical design of the flood monitoring prototype. It integrates several sensors, including a rain sensor, ultrasonic sensor for water level detection, and a moisture sensor. These components are connected to an Arduino Uno microcontroller housed with a protective casing and mounted on a 5-inch parallel pipe. This pipe includes a cord float inside, which reflects ultrasonic signal to measure the flood level accurately. The processed data is then transmitted to a web server for real-time monitoring. Yeah, this result demonstrates how system effectively combines hardware and software components to provide real-time flood monitoring. The integration of sensors, microcontroller, and interface website ensure accurate and accessible informations, helping users make informed decisions during flood events. In conclusion, these IoT-based flood monitoring systems offers a significant improvement in disaster preparedness. By delivering real-time, accessible data, the systems helps mitigate the risks and impacts of flooding. We hope these innovations contribute to safer and more informed communities. Thank you for your attention to these presentations. I hope these informations shared has been insightful and highlights the importance of IoT in addressing flood management challenges. If you have any questions or feedback, feel free to share them, okay? And yeah, thank you so much. Bye bye.